are you? I'm doing all right. Pretty tired. Got my second cup of coffee. Gonna enjoy suffering with you guys for 5 weeks. Where am I? I'm not gonna dox myself. Sorry. Okay. All right. I'm pretty sure some people might be trickling in, but we'll just go ahead and start anyways. I guess one thing before we start, I'm just going to ask kindly that you don't follow, sub, or donate or trigger any of my alerts because I forgot to disable them. So I don't want it to bother the whole teaching session. No, this is not a green screen. It's an app from NVIDIA that you can download that does the green screening. Okay, so I guess we can start off with some basic introductory stuff. You guys signed up for 218. This is session 1. I think what I'll do is sometime in the middle of the class, we'll take like a small 5-minute break just to stretch, get water, and do whatever. I'm pretty sure NVIDIA supports GTX cards as well. Okay, so I guess before we start, maybe we should go through some disclaimers since this is a remote learning class. If you can try increasing the audio of Twitch, but if not, I can talk a little bit louder into my microphone. Sounds fine to me. Okay, perfect. Yeah, just maybe try to mess around with your browser settings or Twitch audio. Yeah, since this class is a remote class, um, obviously we're kind of gated by things being online. So, just in general, I guess I'm gonna treat you all as adults. You know what to say and what not to say. Just treat it like you would in a normal in-person class. You guys can spam emotes and stuff. Just don't make it too distracting for other people to learn. This is kind of an open platform, so I'm sure there's some random people that are gonna be joining, like this Jang808 guy. Other than that, I'll try to minimize your suffering upcoming weeks. So yeah, just feel free to ask questions anytime. If I don't see your message, I'm not actively trying to ignore you. Lectures, I'll try to record them. So I'm trying to record this one as well. So I'll post them onto YouTube sometime after the second session. And then I'll give you guys the links after that. Let's see. Does everyone have? I'm pretty sure everyone has the Discord link. I posted it again on Web Campus. Make sure you check that because that's where I'll post all the homeworks and the quizzes and your tests are all going to be there. The book, it's legally provided by Dr. Jorgensen. He gave me the link and he said I could share it with you guys, so I did. That should also be on Web Campus. Let me just pull it up real quick. So it should be under somewhere here in Pages. You'll see, oh, just kidding, not Pages. Files, you should see the Assembly 64 PDF. That's going to be the textbook that we're going to be using. It might not load on Web Campus. It's a pretty sizable file. Oh, it does. Okay. So yeah, we'll go through most of the material here, but because this is a summer class, I don't have the luxury of having 16 weeks to teach you these. We only have 5, and it's going to be at an accelerated pace. So I might not be able to answer all your questions right away, but after class, or if we have some time at the end, feel free to ask me questions. I'll try to do my best to keep an eye out in chat. Hopefully my TAs, one of them will be in chat answering questions as well if you guys have questions that I might have skipped. Yeah, so I guess we can. Yeah, there's one right now. Here, I'll even mod him real quick. Mod. So I modded him. So he should be able to help you out. We can go over some syllabus stuff since it is syllabus day. Are lectures recorded and available for later viewing? Yes. I'm trying to record it, but this is the first time I've streamed and recorded at the same time, so hopefully it works out. On a scale of 1 to 10, how hard is this course? That depends. I'd say Dr. Jorgensen normally teaches this course, and I wouldn't say it's hard, it's just a lot of work. I'll teach it a little bit differently. I'll try to like keep the same format since you'll probably take 219 with him next semester or something like that. So at least you'll be kind of familiar with how he teaches, just kind of his overall like teaching style. Let me launch up the syllabus real quick. All right, is this readable? I'm sure this is readable. Okay. So, most important thing. Yes, I am your instructor. Hello, hello. You can call me Vince. You can call me Mr. Choi, Dr. Choi, Professor. I don't have my PhD yet, so you don't have to call me doctor. But if you're more comfortable, or you can call me whatever you're more comfortable with, I guess, more or less. Okay, perfect. I don't really have a physical office since we're doing remote, so just feel free to message me on Discord. I'll try to look at my emails as often as possible, but it does get cluttered sometimes with spam. So Discord is probably the best way to reach me at. Let me post the link of Discord in chat as well, in case anyone joining is not in the Discord. Let's see, just here. So that's the Discord link. Okay, so let's go through our syllabus real quick. This is just the catalog description, what this class is about. I'm pretty sure you know what it is since you signed up for it. Assuming everyone here has done the prerequisites, just 135 and maybe 202 for some of you. The textbook is provided on Canvas. Just some general syllabus stuff, not going to do too hard. This is probably the most important thing that you'll look for in the syllabus is the grading, how it's divided. The way I'm going to do it is I will probably do homework is 45% of your grade. Quizzes are 10, quote unquote quizzes. They're not really that hard. Tests are going to be 30%. You're going to have 3 tests. The last one is your quote unquote final. Any extra credit opportunities? Unfortunately, not at the moment. I don't think you'll need extra credit if you're just on top with your work. It's not going to be terribly hard. So yeah, there's going to be 2 tests and a final. Each one is 15%. And that should sum up to 100% of your grade. This is pretty generic grading rubric, right? Your A is anything from 93 and higher. A minus is 90 to 93, and so on and so forth. In terms of if you want point distribution, I think homework is 450 points, quizzes are 100, tests are 450 as well. So that should also add up to 1,000 points. Attendance. So attendance is kind of weird. I'm not really gonna strictly enforce attendance, but if you're not showing up to classes, if you're not rewatching the re-uploads if you missed it, I can't really do much and you'll probably fall behind. And since this is an accelerated class, it's good luck. Academic misconduct. You guys are all adults. I'm pretty sure you know not to cheat. If we catch you cheating, I have to do paperwork, and that makes me unhappy, so don't cheat. You can look through the process here if you want. This is more academic integrity stuff. These are all the things that you're allowed to use as resources. That's not really considered cheating, I guess. Just, common sense class rules, not going to go through that. Here, this might be important for you if you want to look at that. This is the important dates you'll need to know for summer 2. So obviously class starts today. Your last class is going to be on the 9th of July. I think here's the last day of council, which is June 25th. And then if you want to drop without or getting a full refund, I think tomorrow is the last day. Just kidding. It already passed. So yeah, those are your important dates. If you have any disabilities, you can feel free to reach out to the DRC, and they'll notify me for any accommodations you might need. Religious holidays. Yeah, these are just some resources, some general information, exam dates. The good old syllabus stuff. So, any questions so far? Perfect. No questions. I have to disable. Remind me to disable notifications later. Are assignments given on a daily basis? Okay. So assignments, as far as I'm concerned, I have about 7 I want to give out. So roughly maybe 1 and some change a week. Could give you more or less depending on how the class flow goes, I guess. But expect at least 6 to 7. Some of the easier ones will probably cram them in early to get you used to coding in assembly, and then some of the later ones will take you a little bit longer. There's going to be roughly about 10 quizzes, I would say. I'm trying to do maybe like 2 a week just to kind of engage you, see how well you guys are doing with the material. They're not terribly hard, and most things should be answered in the lectures. In terms of submission, I think the midnight rule applies. So just turn it in before midnight of that day. It should be good. I think I went over tests. Oh, office hours. I guess I didn't put that in the syllabus, but so we have 2 TAs. We have Xavier, who's in chat today for this course, and then Kalen might be in the other one. But are tests required to be taken at class time? Yeah, tests are going to be required to be taken at your section time. It's just the best way to prevent cheating, I guess. It's not going to be a lockdown browser, so you won't need webcams or anything. It'll just be like your scheduled take your test from 1 to 2:30. When is this class end? 2:30, I think. Yeah. Aside from this being assembly and not like C++, is the real difference from coding in general. So you're exposed to C++, which is a higher level language, and you generally don't have a lot of nuances to take care of because the compiler or the built-in language has support for those things already. But in assembly, it's all you. So we'll go over some differences in assembly and C++ in the lecture today. So I'll probably be able to answer your question better when we start the actual lecture. Okay. Any other questions? So moving on, I did upload your assignment 0. Hopefully you saw this. Assignment 0 is not really worth any points necessarily, but it's just to kind of get you set up on creating your Ubuntu environment. Any Visual Code extensions you recommend? For assembly, not necessarily. I didn't use Visual Studio when I did this class it's been a while, like 5 years ago, 6 years ago. Any text editor works. Yeah, so that's your preference, I guess. Here's just a brief overview of your assignment 0. Basically, we want to be using some sort of Linux environment. We typically use Ubuntu in the department, so that's kind of what we're going for. The labs at the TBE 311, I think they're open. I'm not 100% sure, but all of those have Ubuntu on them. You can dual boot Ubuntu. You can use it as your primary OS, or you can do what I do and just use a virtual machine. So here's just some installation processes you can do to get Ubuntu on. Just follow this link and download VirtualBox. The reason why I recommend VirtualBox is because it's free on all OSs. I think some other VMs like VMware aren't free on Mac or some other weird things, but VirtualBox seems to work more or less for all OSs. Then you want to get an installation copy of Ubuntu, which is free. The current one that I downloaded was version 20, the LTS version. What's important is that whichever version of Ubuntu you have, I think 16 or above works. 18 definitely should work, but you want the LTS version and you want the 64-bit architecture. I don't think anyone this day and age is using 32-bit, but just in case, LTS 64. Do you want me to go through this? I don't think I really need to go through the installation, but I can launch it up real quick if you want me to show you. Just type yes or no in chat, I guess. All right, perfect. No one needs to see the installation process. Okay, so some important things once you do get Ubuntu added on is you open up your command terminal. Are we gonna do a clean installation? You can do a clean installation. That's what I did just to make sure like everyone who's starting new has all the tools and resources. But you want to at least do your updates, your upgrades, and then you want to install YASM and your debugger DDD. I think you can use a different debugger, but DDD is what I used when I took this class back in the day. Why not do sudo apt-get automove to clean things up? You can. I mean, this is just one way of doing it. As long as everything's functional, there should be nothing wrong. Oh right, you can use your own OSs. I know some people have messaged about different Linux-based OSs, and as long as the assembly file that you submit works on the grader's machine, then it's perfectly fine. Like, I'm not gonna ding you for not using Ubuntu. Just make sure your code works, and if it doesn't work, you can only blame your OS. All right, so that is assignment 0, and assignment 0 right here, the way you get points for this assignment is if you go to quizzes and then you take the assignment 0 quiz. I'll do student view so you don't see the answers, but you'll take the quiz, and then it should be pretty straightforward. It's 3 questions, 3 points. Not worth the complete, or not worth a lot, but at least lets you get familiar with taking quizzes online and tells me that you followed instructions. So nothing too major there. All right, so any questions about assignment 0 before we move on? Give it a few seconds. C86 is pure assembly language. Okay. Do we take quiz now or later after we install Ubuntu? I think as long as you do it before midnight of what was that, Wednesday, the 9th? As long as you do it before then, you're fine. You can take the quiz whenever. It should be open by now. I think at 12. Yeah, it should be open by now. So Visual Studio Code can support assembly language. Well, I mean, it's whatever text editor you want to use. Like, I'm not. That doesn't. That doesn't really matter. VS Code. Yeah, exactly. So I mean, you can do it on the default Notepad for Windows if you really wanted to. I would strongly urge against that, but you can do it. It's doable. Oh, right. One thing that I do want to recommend is that you set up some sort of cloud saving device, just to transfer your files unless you want to do command line and SCP things. Okay, I need to disable bits as well, at least during. Are we going to go over how to compile and all of that? Yeah, we can go over that kind of stuff. But today's not a coding day. Today's more of a review and getting your feet wet with some assembly stuff. Yeah. I probably won't assign you your first coding assignment until, let's say, Wednesday, maybe. That's when assignment 0 is due. I said I strongly urge you to use some sort of cloud saving device, like say Dropbox or Google Drive or something. Yeah, so you can just transport it. So the thing is, if you're using a virtual machine, there's a possibility that it can crash or get corrupt, and you'll lose all your data. So like, as long as you back it up somehow, that's what I would recommend. A cloud device is just easier, but you can choose whatever. Yes, you can also mount a shared folder. That's true. Okay. So, any more questions about assignment 0? Yes, if you're in the second session, you can join this session. I'll basically be going over the same things in the next session. So once we get to like harder material, you can, feel free to join either sections and rewatch the lecture videos. But the caveat is when we're doing our tests, I think. Here, let me pull up the syllabus. Um, that's not the syllabus. When we're doing that is also not the syllabus. We're taking tests, since it's going to be at your section time. Um, you're going to take your if you're in section 2, you're going to be taking your test at 2:40. I think that's what it is. Your first test is going to be sometime in week 2. I haven't decided if I wanted to do it on a Friday or some other in the middle of the weekday. But I think tentatively I might just assign on Friday just to give you guys the weekend to do your assignments and stuff. Okay. Friday works. Yeah, I think Friday might be a good day to shoot for. But we'll see how far we get into the material, because I want to cover a certain amount of material before I give you your tests. So we'll see how our pace works. Okay. So if there's no more questions, I'll start the actual lecture for the day. It's not going to be too painful, hopefully. Let's just go ahead and start a new line. Oh, I fucked up. Dark mode? No, this is Photoshop. I don't know if it comes with dark mode. Never bothered looking for it. Okay, so let's see. Is this big enough for everyone to see? I'm gonna assume so. Yeah, I do Photoshop because I draw my free time. Okay, so we'll just do some review, I guess, from your 218 or your 135 days. So when you're in 135 and 202, you work with C++ or C. I'm assuming you did C++ or something like that, right? So you have your source code, right? So this is your like hello world, right? See out hello world. Then you go ahead and then you call your compiler, right? I think it's you guys use G++, and then you create some sort of an object file, right? Okay. And then they have you call your linker as well. And then that generates your executable file. Let me. I think some of my webcam is cutting it off. So let's just move here. All right, so that's more or less what the flow of your code goes through, right? And this entire process is called a toolchain. It's just the fancy job security word for this process. Okay. Now the difference between will notes be posted? I can post the Photoshop file if you want, and then you can throw that onto an online editor and look for it. Yeah, but I mean, if you're just following on a lecture, you can rewatch the lectures as well. You'll be able to have these notes, no problem. Okay, so that's your C++ language. But when we go to assembly, is your assembly file, right? So this is your source code for assembly. And then instead of using a compiler, we use the assembler. And that will generate your object file. So it's the same process, more or less, except for the compiler versus the assembler. And then once you get your object file, you'll link it and then get your executable. Okay. So not a major difference, but there are some caveats about each of these things. So, for example, if we were to say, let's take a really intermediate code, something like in terms of pseudocode, maybe we'll have like a equals x plus y times z, for instance, right? In C++, the compiler takes care of your order of operations, right? You assume that this operation would take precedence before the addition operation, correct? So in C++, this will just spit out whatever y times z is plus x. But in assembly, we don't have that luxury because we have to. It's basically the machine language, right? We're getting as close to machine language as possible, and precedence is not implemented in assembly. So you manually have to actually first grab your variables, right? So you have to get your y and then you have to get your z. Then call some sort of multiplication on it. So multiply. And then you have to grab your x, and then you have to add those results, and then store it into your variable, say, store to a, right? So this is not actual coding, this is more pseudocode for assembly, but that's kind of the process you have to do since you don't have precedence. So it's like a very bare bones kind of thing. Like things you take for granted with your compiler, like things you assume your compiler would just take care of, you probably have to implement it in assembly. That's one of the major differences. All right. So any questions between assembly and C++? Yes, this class is going to make you humble. That is a very good interpretation. So we would have to write, you would have to write 6 lines. So like this 1-line code in C++ would take you 6 lines, more or less. And then you'll get more excited when we start doing loops and other statements where you jump around. Okay. So I'll start a new page. Okay. So some other things I don't know if you more or less take for granted, but we'll go over some architectural stuff. Does commenting your code work the same in an assembly? So I think in C++ use / to do comments. You can do comments in assembly by using semicolon, I think. I have to revisit that, but yeah, I'm pretty sure you do it with semicolon for assembly. So we'll go through some architectural stuff. C++ source code actually turned into or stored as assembly code during compilation. The compiler actually does that for you. So like there's like some processes where you go from source code, then your compiler will do all the middle stuff. Or in some other language, they'll translate it into something that assembly can read. And then the assembly gets passed into your executor. Go over fun. Okay. We go over some nomenclature and architecture, I guess. And I think it's 2 ends in this. Yeah, I think it's 2 ends. Okay, so you probably are exposed to this architecture already, but you probably didn't know what it was called. So in the von Neumann architecture, we will start with our CPU, right? This is the thing that runs everything in your computer. Now the CPU is connected to all its other parts. There's something called a interconnector. Or a bus. That's what it's most commonly known. So you also have your RAM. So if you ever built a computer, you're probably familiar with a lot of these parts. RAM can also be called primary storage. And then also connected to the bus is some other devices that are also storage, but these are your secondary storage. So these are things like your hard drives, solid states, SD cards, I guess you can use those. Maybe you can use USB like flash drives and all that other stuff. So these are just secondary devices to store information and data. And then lastly, you have your I/O devices. So these are for input output. So you have your monitors, you have your keyboard, your mouse, so on and so forth. Is the bus the motherboard? That's a good question. I guess you can kind of consider that a bus. It does connect all your parts together and feeds the information. So yeah, I guess that's more or less a motherboard. But I think your motherboard does other stuff as well, so it's not just its sole purpose. Okay. So in terms of primary and secondary storage, the main difference between the two is what we call whether the memory is volatile or non-volatile. So I guess this might be a good word to have volatile. God, can't spell. And then this would be non-volatile. So the difference between volatile memory and non-volatile memory is simply if you turn off the power to your machine, does it retain the information? So if we look at RAM, for instance, right? When you power off your machine, all that information that was in your RAM just gets deleted and it's lost. Although some RAM nowadays, they kind of retain information, but more or less, we consider RAM to be volatile. So non-volatile memory is stuff that's on your secondary storage devices usually. So like all your files that you save on a hard drive or a flash drive, those don't get lost when you turn off your computer. So that's what we call non-volatile. Right. So any questions about the von Neumann architecture? Assume everything is fine. So I'm going to move on. All right. So in your CPU, on your CPU chip, you have a lot of things going on. But for today's class, we're going to be more or less covering registers. So these registers. So these are more or less built into your CPU chips, and they're a source of temporary storage. Most CPU chips nowadays are in 64-bit architecture. Just and don't know if they still produce 32-bit, but most things that we're going to be working with in this class are going to be in 64-bit, and it's okay to occupy less space than 64 bits. So what are registers and what do they kind of do? So inside of your CPU, I forgot exactly how many registers you have. I think roughly 16. But they all have different functions. But we'll first start off with just storage sizes, I guess. So we'll start off with byte. So everyone knows how many bits are in a byte, right? We have 8 bits per byte. Hopefully you all knew that already. These are, so for words, we have 16 bits or 2 bytes. double word. You can also call it D word, I guess. This is going to be 32 bits. And quad word. Sometimes call it keyword. 64 bits. Me over just a tiny bit. So in maybe C++, you can consider this as char. You can have words are not typically used, but sometimes used. They're shorts. Doubles are D words. Sorry, they're more integers. Your unsigned ints, floats, all belong in this category. And then your quad words are your longs and your doubles. So I think you should be familiar with that. Now, the size of these things is important because these will map into your registers when you start storing information. Start new tab. So back to our registers. These are inside your CPU. We'll start off with the letter ones first before moving on to the numerical ones. So one of the first registers you'll probably see is RAX. So all RAX is just a temporary storage memory, right? Worth of 64 bits. So 0 to 63. And you're just storing your bits of information in these 64 slots. We can divide RAX into halves. And we can say that this piece right here, the lower 32 bits of this, would be called EAX. If we were to subdivide this in half again into the lower 16 bits, this piece right here be referred to as AX. And then one more time, when we split it in half again, the lower A bits is going to be called AL for A lower. And then you can probably guess what the upper half of this would be called, A half or AH for A higher. Okay. So if we were to declare something like a double, right? We declare a double, and then we assign some value to it, right? Let's say 2. Right, double whatever double A equals 2. It's not really how you would do it. Maybe like you would fill this register basically with a bunch of zeros until you hit 2 at the end. So it'll always try to fill in. It'll read from this way or going another way. So yeah, if you're declaring something that uses 64 bits like a double, you assign RAX that value that we just had. If you want a smaller sized variable, you can call EAX, AX. These two are interesting because these are typically only found in the alphabet registers, I guess you can call them. So the relative registers to RAX are RBX, RCX, and RDX. And these are going to have the same structure. So if we were to divide this into the 64 bits, RBX would be the entire 64, and then you can guess EBX is the lower 32, BX, and then BH, BL. Same thing, we have RCX, ECX, CX, CH, and CL. Same thing, RDX, EDX, DX, DH, and DL. This so you can see. Do you guys want the webcam or not? Because the webcam does kind of get in the way, but I don't mind moving the notes over if you can see better. So any questions about REX? What does the RE and X mean? That's just a naming convention. I'm sure they have a reason for that, but you won't be assessed on your knowledge of what they mean necessarily. The most important part is just this middle piece. This just kind of tells you that this is register A, this is register B, and so forth. Some of the other registers have different naming conventions that make a little bit more sense, and we'll go through that a little later in class today. Right. So shorten the camera a bit. Okay. Let's see. Let me adjust real quick. Okay. Is that good? Okay. Perfect. So let's go over some more registers. I'll start with the numeric ones because those are generally the ones you'll store information on. So we'll have registers R8, R9, R10, all the way to R15. So these are your numeric registers. These are a little bit more intuitive to use, personally. Why is it important to name sections of RAX? Sorry, I missed that question. So it's important because you want to know which part of the register you're accessing, right? You don't really need to access this part of the register if you're only storing like a char, right? So if your char is only like I don't know, like 02, right? You just store it into this part of the register. And when you ask, when you want to pull from your register, kind of think of them as like variables that hold information, I guess. You'll say like, oh, I want to access this specific part of the register. It has 02, right? So you'd say, get AL, that it'll return 02. But if you were to change something like, let's say, you wanted to keep the first part of RX, but not the second part, then you can store multiple values if it can fit in the registers, basically. So you can store like I don't know, like 1 4 into AH, right? So you'd say like AH, you store this value in, and then you can change AL to, let's say, 02, right? And this will effectively make your register look like this. So if this was AH and AL, you'd have something that looks like that. And then you changed AL after that, and it'll overwrite this. So I'll just delete the entire thing, and it'll overwrite it. But now you can access AH if you only cared about the 14, and you can access AL separately. We'll go over some examples. Okay. So moving on to the numeric ones. The left side of EX is not called anything. So there's really no way to access this unless you want the entire RAX. Quite generally, this is like doing something like this is quite awkward. You might as well just store them individually in different registers. There's some practices where you do that, and sometimes it is important in terms of like addition, multiplication, and just arithmetic in general. They might carry the bits over to the next register if it needs it. When we put things on the stack, is that just the register? Can you elaborate on that question? I think I know what you're asking, but I just want to make sure. Stack versus. We are gonna go through some stack stuff using registers. I'm pretty sure. Is a stack just a bunch of register storage? Kind of. Stack is part of the stack. The stack is an abstract concept, all right? So if you were looking at a stack, somewhere you would have like a stack pointer telling you where on the stack you are. And the registers just exist as memory. So these storage registers don't necessarily have anything to do with the stack. The stack is more like your instructions that you're putting in, right? Like get A, add, get B, stuff like that. These are like your instructions, and then they will reference whatever registers you're using, and those registers can be put on a stack too. But yeah, you need to turn off notifications tomorrow. Yeah, we'll be using a register specifically for the stack, so that'll come up in later assignments. But let's go ahead and talk about the last part of these storage registers, because these are notated a little bit differently than the alphabet ones. So sometime after they invented RAX, RBX, RCX, and RDX, they thought it was a good idea to start using numbers instead of letters. So there's a little bit of inconsistency, but when you look at a numerical storage register, R8 is going to be the entire register, just like RAX would be. So this would be your 64 bits. If you want to access 32 bits, you would call R8D. So just replace the middle number with whichever register you're working on. And then D for a double word, so that would make sense, right? D for double, which is 32 bits, or D word. And then splitting this in half, 15. We would call this part RAW for word. And there would be no way to access specifically the lower 8 and the upper 8, just like you would in the alphabet ones. The numeric ones don't have a reference to these two parts of the register. But it keeps it nice and simple because in general practice, you never really need to specifically access AH or AL or maybe AL, but if you just call R8W, right, it will just grab this entire thing. And if it's zeroed out, normally it would be zeroed out if you don't exceed the bit limit, then it would just give you the bottom, like the bottom half of it with zeros at the end, or at the front, sorry. Hey, any more questions about storage registers? So I guess we can take a short, maybe 3 to 5 minute break. Feel free to ask questions, doesn't have to be related. Is this type of naming a specific architecture familiar with MIPS, which doesn't use RX, uses R1 to R31? Yeah, so this specific type of register naming is for x86. So the first, I'd say 4 weeks of this class is going to be on x86, and then the last week we will dive into a little bit of MIPS. The von Neumann architecture isn't really doesn't really do anything with these registers. It's more or less how you see your entire system, like how your parts connect. We can talk a little bit more about the von Neumann architecture. What do you mean by AVR? They are making advances. Do you think there'll be more emphasis on market stuff? I think learning assembly is pretty important for computer scientists, right? Like you can teach anyone to code in like C++, but then like to actually understand how that functions in your computer and how you can make those like cuts and stuff and optimize things. That's kind of like where the assembly stuff comes in. So I mean, if they do add more architectures, like there needs to have some way of translating it into some sort of assembly code. So I don't know if that answers your question, but I mean, I would say like learning assembly is important. So I don't know if that has a huge impact on ARM, but yeah, different architectures will have different register names. We'll be doing MIPS later on. So I think your first two tests is going to be in x86, and then your last test or your final is going to be mostly on MIPS. So we can continue on with some register stuff. Just the last bit of it, and then might let you off early. Okay. So there are some other special registers. I won't go through all of them today, but just a few that are kind of important. We have RSP, which is your stack pointer. That's kind of what we talked about earlier. That's pretty self-explanatory. It will point to the top of the current stack or whatever stack that you want to be pointed to. You're gonna have to deal with this and update it to make sure your stacks work, or like the flow of your instructions will be jumbled if you don't. We have our IP, and this is your register for your instruction pointer. Also very important because this will point to the next instruction to be executed. So if you change this, you might never be able to terminate your code because you lost where your code should logically flow. So yeah, unless you know what you're doing, I would highly suggest not touching this this instruction pointer to store information other than where you want it to point to. And then we have our BP, which is your base pointer. And this is for your function calls that we'll do later. There's also RSI and RDI, but we won't talk about it right now. Why is it named RIP? Well, it's the register for your instruction pointer. So RIP. That's why they named it that. Right. Other than that, we can maybe go over some parts of the quiz, I guess. Unless you have any other questions. Or maybe I'll revisit the von Neumann architecture just a little bit. RIP as in you missed this and messed up? No, I just chose not to acknowledge it. Let's see. Let's go back to von Neumann. This one? Definitely this one. So I guess we can kind of talk about how information is transferred. We'll be using these registers for our data storage. Yeah, more or less you'll be using all the registers we mentioned today. Obviously the latter three, oh, I changed it, but the three that I just mentioned with RIP, RSP, and RBP, these are going to be used specifically to do stack stuff, instruction stuff, and function stuff. So you won't be storing information here, but you'll be storing information in the alphanumeric registers, RAX and the R8 to 15. Okay. So going back just briefly about the von Neumann architecture, we'll just talk briefly about how data is moved. Let's see, Is it easy to run out of space? I don't think I've ever ran out of space when hosting programs for this class, so I think you'll be fine. And most of the times, I think I've only used like 5 registers at most. Okay, so just really briefly, how data. Oh, what did I do wrong? Here it's hidden. Oh. So really briefly, let's say if you have a program on your secondary storage device, how many registers per CPU core? Moving data is chopped up into data called packets. Packets normally deal with data that moves through the network. We normally don't call information that's passed inside your internal hardware packets. So, I mean, I guess you could, but. So if let's say like we had a program, I don't know, some kind of video game you play on Steam, right? So here's your Steam program. And it's stored somewhere in like your hard drive. So what happens is that in order to play your game, we'd actually have to load. I'll use a different color. We'll have to load the game information. So it goes through the bus, and then it goes into RAM. So the game will live on somewhere in your RAM, and then it'll pass into your CPU to run. That's basically it. You might go through. I don't know if we'll go through virtual memory in this class, but I could teach you that sometime later. That's basically when, let's say let's say you only have 8 GB of RAM. Very sad. And your program is unfortunately 10 GB. It's creating virtual memory allows you to load certain programs and use certain resources more optimally, so that obviously not all 10 GB of the information in your program is loaded at once. It will do something in RAM that will allow you to just use the parts that you need. But that's more or less how data goes through in the von Neumann architecture. We can maybe talk about your quiz that you have today. Maybe I'll go back to student. Oh, that's the wrong quiz. Did I not upload your quiz today? Ah, that's probably why. All right. What about question? How many registers per CPU? Oh, okay. Sorry, I thought I read that as a statement. How many registers per CPU or that depends on your CPU, I guess. Yeah, that's a hardware thing. But you should have all the registers that are in that we listed today. Um, any other questions before I move on to your quiz? Okay. So you'll have until the end of today to finish this. Um, okay, let's block this. Let's block the bot. All right, so it should be pretty straightforward. I think it's 9 questions. The last one is worth a little bit more just to get the full 10 points. Yeah, I just published it, so if you refresh, you might be able to see it. I think if you're in section 2, I might not have published it in section 2 yet, so I'll do that when I teach section 2, I guess. So they're pretty straightforward questions. Here, I'll test the streaming app, I guess. Where is it? Okay, let's do a poll. How many bits are in the RAX register? Okay, we have option 1, 64. Option 2, 16, and 8. Okay. How long should I set the time for? Let's make this 1 minute, so 60 seconds. All right. See if you can see this poll. I'm planning to do 2 quizzes a week. Probably make it like maybe Wednesday, Friday, or Tuesday, Thursday. This one being an exception since it's just to test out the whole quiz things and get used to it. Yeah, so type exclamation mark vote and then type in 64, 32, or 16 or 8, and then we'll close the poll and see how you did. Vote 6. Can't vote 6. Sorry, registers don't allow for that. Everyone's a bandwagon. No one wants to be different. Vote 8. Ah, there we go. Vote 8. All right. Well, the correct answer is 64. So if you're paying attention, it was indeed 64. No, can't vote for 420. Not a exponentially divisible number by 2. All right. And then yeah, so the quiz is more or less pretty easy. There's one for EAX, one for this is a trick question, and then one for AL. All right, then you got to name the 5 components of the von Neumann architecture. Not too difficult, right? We just went through it. Describe what a tool chain is for assembly code. Just tell me what the process is. This thing we covered in the review. List some secondary storage devices. No. Hard. Oh, even a true. Oh, I was so generous. I gave you a true false. Okay, assembly does not have precedence. Okay, let's ask the chat room whether or not assembly has precedence. Let's see, 60 seconds. Does assembly have precedence? Option yes. Type in command Y and no. Okay. All right. Flow is underway. Oh, I have to see. And all right, second poll. I'm seeing a lot of yeses. Any no's in chat? No, no voting 420. Vote yes or no. Uh, maybe I should have worded the poll a little bit better. Yeah. Right. And you got 14 yeses, 10 nos. Yeah. Question is where? Oh, yeah. Bad poll. Just answer it how you would answer it on the quiz. Okay. So that was a trick question since it was worded terribly. Yes, as in true. Sure. Yes, as in true. Okay. Let's just close down the poll. All right. Pretty divided, probably because I worded it terribly. The correct answer to this question is true. The programmer must declare the order of operations. It is not, you cannot take it for granted, just like you can with the compiler. Okay. And then last question we'll cover, and then I'll let you guys go early. Ask questions if you want. This is an interesting one, so I'll read it. Maybe I'll copy it. So AL is selected or is set to 0, 1, and then EX is set to this string, and then AX is set to this. What will the final contents of the RAX register be? Assuming the RAX register was zeroed out to begin with. So let's go over this one. So let's. So what did we? Oh God, stop. So what did we say? We had 0, 1, 3, 20. So it's like we have set AL to 0x01, then EAX to 0, 0, 0, 0. Zero, 2, 8, 9. And then final contents of RAX. Actually, all of these are technically wrong because there should be 4 more zeros, or so there should be double the amount of digits. So there should be an extra 8 zeros. But so I'll just walk you through this real quick. So first, if we were to draw our register, this would be AX. Half of it would be AX, AL, and AH. So first, all of this is all zeros, zeroed out register. We're going to first change the contents of AL to 0, 1. Okay. Then we're going to change the contents of EAX to this right here, so 0, 0, 0, 0. Then I'm missing an extra 0. Then we have 0, 3. And then when we overwrite this last two part, we're going to overwrite this and fill it in with 20. Then we're going to change the contents of AX, which is this lower 16-bit. And we're going to change the contents to 0, 2, and 8, 9. So now your register is going to look like this. I think on the quiz, I might have done some typos. Yeah, but correct answer should be this first one. Think you should be good for the rest of the quiz questions. Is there any other questions before I let you go? Okay, sounds good. Is the VM installation relatively not too complicated? Yeah, the VM installation is pretty straightforward. So here, I'll launch it real quick. So basically, you'll be in this VirtualBox like that. I already have the VM installed here, but all you have to do really is to add a no, not add, new. Go away. Um, you're gonna add a new one. You can name it whatever you want. Here, we'll just call this let's you can put it wherever you want, and then you can set the amount of memory you have. So for RAM, I guess this will be dependent on how much RAM you have on your own system. I had 64 gigs of RAM, so I just set aside like 16. But that's pretty overkill. You can probably get away with like 4 gigs, 2 gigs. Um, when will the VOD be on Twitch? I have no idea when the VOD will be on Twitch. Um, but I am recording it, so hopefully I can also upload it onto YouTube. I'll probably only upload section 1 since that's where most of the class attendance is. What is the tool chain again? The RAX of the other? No, the tool chain is the process of going from source code to executable. How in depth should you describe the tool chain? I don't know, just enough technical jargon to get you a job. No, yeah, just describe it briefly. It's not a hard question. It's pretty straightforward. Just start to finish from source code, where it goes through, what happens in the middle, all the way to the executable. Yeah, once you set up this, you can allocate some memory, and then you just create it, and you'll have Ubuntu. When you load it, it'll ask you for disk image, and that's the disk image you download from the Ubuntu website. And that's pretty much it. Then once you're in Ubuntu, see if I can launch it. Once you're in Ubuntu, look like this, and then you'll go to your terminal. So yeah, you'll go to your terminal, and then you'll download the updates. Yeah, so you'll do your sudo apt-get or whatever commands you need to do, get your updates, and then you should be good. So yeah, shouldn't be too hard, right? When do we expect the notes to be posted? I'll upload the Photoshop file. Let me see. Maybe we can go. We can see if there's a. Since not everyone has Photoshop, open Photoshop file online. Yeah, you can probably just drag the file into this website probably, and then you can see it. Maybe I'll save it as a few images and then stitch it as a PDF if you wanted to do that. Um, but since the lecture notes are uploaded, or the lecture itself is uploaded, I don't think you need to worry too much about that. How's the exam structured? Good question. I haven't made the exam yet, so I can't tell you. The quizzes are kind of like more or less how I gauge what kind of questions are good for Web Campus. Is the bus a component of the von Neumann architecture? It is. It is very important because if you don't have a bus, then your parts can't talk to each other. Can you save it as a PNG or GIF? The problem with that is I have to save it as multiple PNGs. I mean, I could do that, but I'm also very lazy. Okay. Yeah, I'll upload it somehow. Let's see. I don't know if others will have this problem, but I need to change BIOS settings to allow a VM to run. Yeah, you might need to. I don't know what privileges you have on your own devices or what kind of yeah, administrative stuff you need to do. But yeah, do what you need to do to get the VM to run if you are using a VM. Any other questions? What's the alternative to using the VM? You can dual boot. You can go to the lab, and you can use a text editor and pray that your code works. So yeah, that is because it's in hexadecimal. So hex takes up more space then, or it takes less, notationally less space. You need to allow virtualization in the BIOS, which should be easy. Yeah, I'm sure if you have a specific problem, you can ask one of the TAs. You can ask me, or a quick Google search will probably get you the answer as well with pictures. Yes, the 0x notation is it's exactly that. VirtualBox keeps crashing me when I try to boot. Might have to ask Discord because I'm not sure what's going on. What it might be a hardware specifics, I guess. See, just have crashing with booting problem for a while. Found out BIOS fix might fit. Yeah, the 0x is hexadecimal. Otherwise, it would be a pain for me to write out like 17 zeros for like one register. I'm on Mac OS. Maybe I did. I personally did mine on PC. I mean, Mac should work, but uh, it might depend on your hardware settings too. I don't know how strong of a hardware you have on your Mac, but I've done it on a pretty cheap laptop, so it's shouldn't be a hardware issue. Sounds good. I will see you tomorrow. stop the recording for section 1 here.